best you can, make a right triangle and tear off that excess that it gives us. Mine didn't work out super great, but it's something close to a square. I keep moving that.
Oh, you're fine. You're still in frame.
So once you have your square, let's hold that up. Ah, she pulls out these scissors. Is it cheating or is it smarter? Work smarter, not harder, right? Yeah.
All the way. Okay.
So this is going to be our rectangle that we're using to do multiplication of fractions. Right now, this rectangle has a length of 1 and a width of 1. So what is its area? 1 square unit. So this is 1 times 1 equals 1 square unit. That's not what we want, is it? What do we want our length to be? 2/3. So we need to turn this into 2/3. So the first thing we're going to do is we're going to make thirds. And then we'll open it back up. So if you hold it up and put your thirds on the side, so that's our length. Now we have, what's this? It's 1, 2, 3/3 times 1 equals 1 square unit. We don't want 3/3 times 1. What do we want? 2/3. So 2/3 times 1, area is 2/3 square units. Anything times 1, right? Identity property. But we don't want 2/3 times 1, do we? What do we need to do with this? It needs to be fourths. So I'm going to do half, and then half again. Has anybody done this before?
Yeah, I think so.
The first person I've ever come across.
Not like exactly the same, but I definitely remember folding a lot of different papers.
So then when we open this up, we have 2/3 times 4/4. So we're going to fold one of those back. So now we have 2/3 times 3/4, and our area should be 6/12, and we should be able to simplify it to 1/2. So let's take what we have showing now, this area that's showing, and shade that. Once you shade it, open it back up. How many pieces are shaded? How many pieces are shaded? 6, right? How many are there altogether? 12. Is that not how we write fractions? The number that we have over the number that there is altogether? 6/12. Now, let's see if we can simplify this. Is this the same as this? Yep. Is that the same as that? 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 And that the same as that? So half of it is shaded. So we just simplified it. Concretely multiplying fractions. If we wanted to represent this pictorially, we do the exact same thing. I draw a rectangle. I cut it into thirds. And I'm going to shade 2 of those. It's ideal if you use multiple colors. I'll just go different directions. And then I'm going to cut it into fourths. and I need to shade 3 of them. How many are shaded both directions? Not a rhetorical question. How many are there altogether? 12. We've done concrete and pictorial. And then we would move into the abstract. That's when we would then go to this. And we would start representing it that way. So that's just an example of one method of concretely representing a concept for students so that they can build it themselves and more easily retain that information so that it can be recalled. Now, let's talk about these 3 E's that I wrote down up here. All mathematics should fall in the category of 3 E's. Number 1, it should be exact. It's not okay for me to say that this is about 5/12. No, it's really 6/12. We need to be exact with our mathematics. When you're doing writing, if you're teaching ELA and you're doing writing, creative license comes into play. So there's a lot of wiggle room with things. Children can choose a variety of words to represent the same exact thing. Mathematics, it's not that way. You can get to the point a lot of different ways, but that point you get to is always the same. It needs to be exact. We also need to be efficient. But efficiency can give way sometimes to elegance. So, while repeated addition is not the most efficient method of representing multiplication, if a child cannot understand this, or this, or this, repeated addition might be efficient for them because it's elegant. Elegant meaning it makes sense and has appeal for that individual. Now, it doesn't mean that we should let them stick with repeated addition forever. When they start multiplying 56 times 75, repeated addition is ridiculous, isn't it? This is my analogy I always get. It's like you're going to Boston and you have 2 vehicles to choose from. Are you going to drive the Suburban or the Prius? Not a rhetorical question. The Prius, right? But if the Prius is broken down, or for some reason you don't know how to drive the Prius, maybe it's not a Prius, maybe it's a small car that's a stick shift, you might have to take the Suburban until you can learn to drive the Prius, or the whatever else that's efficient. So, efficiency can give way at times for elegancy, but the goal should always be to reach the most efficient method possible. I normally would do another little math lesson with you guys on finding the least common multiple and greatest common factor. If you guys would like to do that, I will, because I love doing this stuff. But if you guys would not like to, we can kind of move on. You guys want to do LCM, GCF? Greatest common factor? Okay, so there are very many ways to do this. I'm going to do just a really brief thing. Most people, when they're doing LCM or GCF, they go through, like, let's say we're trying to find the lowest common denominator. We would have to go through least common multiples for things. We have to find the least common multiple. So if we're finding the least common multiple for 2 numbers, a lot of people simply write out both numbers and they start doing the multiples. So let's say it's 6 and 12. We know that it's 12 already, but I should use something. 6 and 15. You'd write out your multiples for 15. Yeah, it's 30. You might go a few past 30 just to be sure because you're not positive. And then you start writing out your multiples of 6 until you see the first one they have in common. Now, is that efficient? Not really. There's a much more efficient method. You can do factor trees or find why is it escaping me? Somebody tell me what this is.
I thought I knew it.
It's a factor tree. Or is it escaping me? The prime factorization.
Oh.
Prime factorization is the most efficient method of finding least common multiple and greatest common factor, and thus your least common denominator. So prime factorization might not make sense to everybody right away. You might have to take them through going all the multiples of a number or a bunch of multiples until they find which ones go together, and then you would work toward prime factorization. All right, that's my math lesson for today. Does anybody have questions? And I mean not questions about mathematics specifically, but questions like you're going to go tutor in the classroom and say you're going to tutor math and you're worried about something you're going to do, or even ELA, tutoring questions, English language arts. You guys are going to do robotics, is that what you're doing? Lego robotics, Mindstorms. Did you guys work with Lego